Hi, welcome to Geography Now. I am your grade 11 teacher, Miss Shana Day, and today we're going to get into calculating gradient. Now, if you hate math as much as I do, I'm just kidding. I don't hate math. Okay, yeah, maybe I do. But anyways, our objective for today is that you should be able to effectively calculate the gradient of a slope and express it as a ratio. Let's get into it. So what is a gradient? A gradient is calculated using this formula. If you have a look on screen, you will see gradient equals to difference in height over horizontal distance. Or if you are deep into geography, we're going to talk about the rise over the run. All right? That might be easier for you to remember. Now let's jump right into working it out. Step 1. Now you find 2 points you'll be working with. Let's call them point A and point B. So you know what you need to do right now, right? Like you need to get a map. You need to get a map right now. Go quick, find it, hurry up. You got it? All right, so you have your map. Let's get into it. Point A and point B. Now, the next thing you do is you find the height of point A and point B. Now to do this, by using the contour lines on your map or trig stations in some cases. So let's imagine that point A is 50 meters above sea level, all right? And point B is 250 meters above sea level as well. Now we're going to subtract the smaller number from the larger one to get the difference in height. Now in this case, the difference in height will be equal to 250 meters minus 50 meters equal to 200 meters, as you're seeing on screen. Now, the next thing is you use the scale on your map to measure the horizontal distance from point A to point B. If you do not know how to do this, all right, now let's imagine once again a horizontal distance between points A and B is 3 kilometers. Now we need the rise and the run to be in the same units before we move on to the next step. How do we do this? Oh, we can convert 3 kilometers to meters by, tell me, you know this, multiplying it by 1,000 to get 3,000 meters. What? How easy was that? Simple, easy. You guys got this. Now the next step is plug your information into your formula like this. Now have a look on screen. Now you'll see the difference in height or the horizontal distance is equal to 200 meters over 3,000 meters. All right? Now, in order to get the ratio, all right, you need to divide both the numerator and the denominator by the difference in height. Now, in our example, this works out to be 1 over 15. We then express this as ratio. We say the gradient of the slope from point A to point B is 1 to 15. And this is your final answer. Now, did that go too fast for you? Don't worry, that's why I'm here. Let me explain it to you. Now, what does this mean? Now, in the example, right, is that the gradient 115 means that on average, as we move from point A to point B, as we go up the slope, we gain 1 meter of height for every 15 meters we travel forward. Now, if you go down the slope, you lose 1 meter of height for every 50 meters you travel forward. All right? Now, since this is a ratio, you can freely insert another unit of your choice. Here, such as, let's say, 1 foot of height for every 15 feet of horizontal distance. Also, now, bear in mind that the larger the number on the right side of the ratio, the gentler the slope is. All right? Now, a very, very, very important tip. I want you guys to zoom in right now. All right? Now, you must ensure that the difference in height and the horizontal distance are in the same units before you calculate the ratio. Now, on some maps, all right, the heights are given in feet and horizontal distances are given in kilometers or even miles. Now, in order to calculate the gradient, you need to know how to convert the unit into another. So you need to know how to convert one unit into another. Now, let's have a look on screen to see this information. If I were you, I would take out my phone, take a picture if you don't have this information, you know? All right, so 1 kilometer is equal to 1,000 meters. 1 mile is equal to 5,280 feet. I hope I live that long. Yeah. 1 meter is equal to 3.28 feet, and 1 foot is equal to 0.3048 meters. Now, let that soak in a bit. Is it soaked in? Yes, because we're like sponges. Now, we're going to show a quick video demonstration of how you can calculate the gradient, following the same example we were showing before. But now you have a visual, you know, for those visual learners. So, let's get into it.
This tutorial is obviously all about gradient. Gradient is about determining the steepness of the slope. Some slopes are particularly steep, while other slopes are much more gentle. This can be relevant to us for a whole number of reasons. It can help us determine where we want to build houses, where we should construct roads, where we should work out where bike tracks or we should run or walk. Also can be useful for planning rescues during emergency events. So here we have a slope, and in order to calculate how steep it is, we need to know two things. We need to know its rise, how high it is. We also need to know its run, how long the slope is. And we remember that, or we calculate that using a very simple equation. Gradient is equal to rise over run. So we talk about gradient in terms of a ratio. So an answer for gradient might be something like 1 to 40. That means for every 1 meter of rise, we have 40 meters of run. Or it could be 1 to 5. Every 1 meter of rise is 5 meters of run. Now, we need to bear something in mind, that the rise and the run, set up as they are both the numerator and the denominator. You would know this from maths. In order to get a ratio, we need to divide both the rise and the run by the numerator. So that would be, imagine that the rise was 60 meters for this mountain, and imagine that the run was 1,000 meters. Now, simply calculating 60 divided 1,000 would not give us a ratio. So we need to divide 60 by 60, and the answer's up here, which gives us 1. Then we divide 1,000 by the 60 as well, which gives us 1 to 16.7 meters. And that's how we calculate it. Okay, let's practice that. So here we have a contour map. It's important that we note that the contour interval for this map is 5 meters, and that the scale for this map is 1 centimeter is equal to 10,000 centimeters in real life. And we're going to be working between these 2 points here, between point A and between point B. So the first thing we need to do is recall that the equation we're using is rise over run. Now, A, let's find out what its rise is. A is at 140 meters. Here is 150. Using this index line, we can track back along to here. And obviously, 145, 140 is where A is. And B, if we come up, here we have this index line, 175, so we're going 5 up, so it's going to be 180. So to find out how high we've gone up, and we've traveled from A to B, we simply subtract the height of A from the height of B, and that will equal to 40. So here we have our rise information, 40 meters. Let's determine our run. To do that, we're going to need to measure the distance between the two, and here on this ruler it is clearly 4 centimeters. So we take our 4 centimeters, every 1 centimeter is equal to 10,000 centimeters, so we times that 4 centimeters by 10,000 centimeters, which obviously gives us 40,000 centimeters. So now we have our run, but here's the tricky bit. We're in different units. This one is in meters, this one is in centimeters. We have to have them in the same units. So the easiest way to do that is we know that if we cancel out 2 zeros from centimeters, just like this, it will convert it into meters. So we take the 2 zeros off, and that will become 400 meters. Now we're ready to calculate it. So we divide the 40 by itself, which gives us 1 down the bottom there. Then we divide the 400 by 40 as well, which gives us 10. So the gradient in this one is 1 to 10. For every 1 meter we go up, we're traveling along 10 meters. Let's try it again. This time we're going to work from X to Y. The contour interval and the scale of the map have stayed the same. Rise over run. X is at 140 meters. I'll let you go back and figure that out to see if I'm right. And Y is at 175. So we simply subtract, that's the wrong way around, we simply subtract 140 from the 175, and that should be 35 meters. So here we have our rise of 35. Let's measure across, bring that ruler in. That is 3 centimeters, give or take. So we type 3 centimeters by the 10,000 centimeters, and that gives us 30,000 centimeters. Obviously, they're in the wrong units, meters and centimeters, so we have to scrub 2 zeros off there, scrub them off, and that converts it into 300 meters. We divide by the numerator, gives us 1, 2, 8.6. There we have the gradient between X and Y. Okay, this is an opportunity for you now where you're going to do it yourselves. The contour interval for this map is 20 meters, and the scale is 1 centimeter to 50,000 centimeters. So calculate the gradient for the following points between C and D. Here is point C, there is point D. Between O and P, O is here, P is right up towards the top there. And lastly, Q and R, I'm sorry that's slightly cut off, but that is Q and R. And Q is here, R is there. You shouldn't find this too hard. The only other information you're going to need to know is the distance between them, and here are your rulers. Best of luck with that. I don't think you'll find it too hard. This is all you need to do to be able to calculate gradient effectively.
All right. Now I trust that video was such a great help to you. And not to worry, calculating gradient is as easy as 1, 2, 3, ABC. All you need is focus and commitment. This was Geography Now with Miss Shauna Day, and I want to thank you for being a part of today's lesson. I hope you have learned. See you next time. Bye.